Now we're ready to talk about the heart of quantum linguistics. What I'm about to share with you is the heart of quantum linguistics. I'm indebted to a guy that used to work with me named Don Anderson for some of this. And Don was a calculus nut. Let's look at page 26. So here's what comprises the heart of quantum linguistics. First is Cartesian logic, and Cartesian logic, Cartesian coordinates, Cartesian logic are four simple patterns that reshape thinking in a multidimensional way. We're looking at slide 20. Cartesian logic are four simple patterns, very, very simple patterns that reshape your thinking in a multidimensional way. Let's talk about why thinking needs to be reshaped in a multidimensional way. One of the interesting things about a quantum mechanical device is that it's multidimensional, not single-dimensional. So have you ever had a problem, somebody walked up to you and says, well, just don't have that problem. And you go, hey, what do you mean? If I could get rid of that red, right? And you get kind of grumpy about it, right? That's because they're telling you in a Newtonian way. It's not our fault. Newton gummed things up 307 years ago. He said, everything is either X or not X. But it's not. Everything is not X or not X, is it? Everything is not just X or not X. See, one of the things we need to look at when we begin to think about how we put things together linguistically is the glue that holds them together. See, and we're tempted. I think it was Wittgenstein that said this. We're tempted to think that just because we know one, that we know two. Because after all, one and one are two. One and one equals two, but he said something very important. He said, we've forgotten that we still need to make a study of and. Whoa. Think about it for a minute. Does 1 and 1 equal 2? Sometimes, Murray. Sometimes. In a quantum mechanical universe, does 1 and 1 always equal 2? No. In fact, sometimes 1 and 1 doesn't equal 2. When does 1 and 1 not equal 2? If you take a gallon of alcohol, pick your favorite kind, and you combine it with a gallon of water, you get 2 gallons of liquid? Do you know? The answer is absolutely not. Never. If you combine in a gallon of alcohol and a gallon of water, you'll never get 2 gallons of liquid. Never. You could do the experiment till the cows come home. And they're home, by the way, already. See? Look. The cows are home. So you'll never get 2 gallons of liquid, I promise you, because alcohol and water are combined in a quantum mechanical way, and the alcohol fits very neatly into the water and combines to something less than 2 gallons. Always. And in interaction with people, are 1 and 1 equals 2? Almost never, because it either equals more or less than 2. If it equals more than 2, it's called synergy. Now that's why we get together with people and do stuff. We get together with people and do stuff because we all get together, and then the sum total of all our efforts makes more than the single total of the efforts individually. And if the sum total of all the efforts together is less than 1 plus 1, it's conflict. Yes, very simple. Either there's synergy or there's conflict. Even in human interaction, 1 and 1 is almost never 2. So what we're going to look now at, what we're looking at in terms of quantum linguistics is the connective glue that holds together the words that we use that we take for granted. And Cartesian logic and predicate calculus are about looking at the connective glue that holds together sentences and words that we string together and use unthinkingly, but that can combine in different ways that will make it impossible for you not to think differently without even having to think about it consciously. Okay. Predicate calculus comes from symbolic logic. If you want to read a good book on symbolic logic, Lewis Carroll thought that his book on symbolic logic was the best book he ever wrote. And do you know which book he hated the most? Alice in Wonderland. He thought that was the worst book he wrote. And so we remember him for his worst book. Alice in Wonderland is an example of symbolic logic. if you read it carefully. And what are symbolic logic? The predicates, predicate calculus from symbolic logic are the predicates that connect the elements of quantum linguistics. Whoa! And the last part of this is the hierarchy of ideas, which just essentially says that we can talk abstractly or we can talk specifically. All right, page 26, slide number 21. In terms of quantum linguistics, these are the two most important things we're going to talk about. The first is Cartesian logic. Cartesian logic, there's no magic to this. How many people have studied calculus? Anybody? Calculus and or quantum physics? Right, great. So you know then in order for a theorem to prove in calculus, it must prove in all four quadrants, which essentially says that the inverse of the theorem must be true, the converse of the theorem must be true, and the non-mirror reverse of the theorem must be true. We need to move to this kind of multidimensional thinking because the human being is a multidimensional being. So rather than thinking X or not X, we need to look at the construction of the problem the client gives us. And also we need to think about how we're going to respond to that problem in delivering the whatever response we're going to give. So, in Cartesian logic, if the theorem is AB, oh, by the way, for those of you who are really dyed-in-the-wool calculus folks, there would be a connector between A and B, as you know. It would be A equals B, but I'm going to leave that out for sake of linguistics temporarily. We'll come back to it if we need to. So if the theorem is AB, then the inverse would be A not B. That little squiggly thing in the inverse before the B is a not sign. The inverse would be A not B. The converse would be not A, B, and the non-mirror image reverse would be not A, not B. There's an example in your notes, even as far back as the practitioner training, which holds true, which in other words, which is a consistent sentence that you can use so you have an example of this. For example, if you said to someone, what would happen if you did, that would be the theorem. The inverse of that theorem would be what would happen if you didn't. Do you see how that's A, not B? Yeah? And the converse would be not A, B, so the converse would be what wouldn't happen if you did. Right? And the non-mirror image reverse would be what wouldn't happen if you didn't. Now listen, if you can begin to think this way, you will be able to think circles at light speed around everyone else on the planet. And I don't know if you know this, but I've been teaching this now for several years. Some of you heard it on the tapes at varying and different times. But what I didn't know was that there's a group of nuns who actually uses these questions as a way to gain enlightenment. And they've been doing it since 1500 AD. That's scary. So where was I? Somewhere else. Okay. So they run everything through this. They call it the four questions, and they run everything through this four-question thing. So your homework. The first part of homework was deliver embedded commands for fun. The second part of your homework is to begin to think this way. At least for the next couple of days, run everything through this. Everything. So sit there and you think, oh, there's my water glass. And you think, there is not my water glass. But then you think, not there is my water glass. And then you think, not there is not my water glass. Do you know what you're running over? Think about it for just a minute. This brings us back to the concept we were just talking about on wall chart number 5. Let me say it again. There is my water glass, right? And the converse is what gives us a lot of juice in this one. The converse is, so you say, there is my water glass, there is not my water glass. That's okay. But not there is my water glass. What does that give you? That gives you the boundary conditions. That actually gives you the boundary conditions that comprise water glass. Because in order to think of water glass You have to know what's not water glass. Do you get that? This is, by the way, the whole thing of figure, ground, and Gestalt psychology. In order to know water glass, you have to know what's not water glass. Wait, can I have a chair? Okay. Is this a chair? Okay, so having this chair here describes chair, doesn't it? But you wouldn't know that this was a chair unless you knew it wasn't a chair. So what is not chair? Everything else. Everything other than this is not chair. And that's the boundary condition between chair and not chair. And that's why chair describes everything else in the universe. It's because it's the boundary condition right here of chair and not chair. Yeah. Could you almost say that this is mapping the territory? You could say that anything you think, let's say this. You could say that anything you think imposes a set of boundaries on the nervous system, which boundaries also describe what's not there. So anytime you have a problem, you have a not problem. Because in order to define the problem, you must also define the not problem. What's the not problem? Solution. That's why we always say inherent in any problem is the seed of a greater solution. Because in order to think of problem, you have to think of not problem. You have to define. So it's just the definition of chair that defines not chair. And not problem, the opportunity of not problem is much bigger than problem, isn't it? If here's the problem in our boundaries, look at all the rest of the nervous system that isn't problem. I mean, you wouldn't sit over here to the right of the chair, would you? Ha! Probably not. Why not? Because you know it's not chair. So chair defines not chair. And this is where we find out what our definitions are. This is where we run through all the notions of boundary conditions, because the boundary conditions don't just lie in the inverse. And it just so happens that the water glass and not the water glass, that they lie in, or not that actually, they lie in the converse, but sometimes they lie in the non-mirror image reverse also. So if you can begin to think this way, what is the non-mirror image reverse of chair? Sure. Well, let's run this through that. Let's think about it a little different way. So what is not chair? Let's do this with chair. What is not chair? Everything else. So this piece of wood here. How do you know? What if Mara takes this up to her school and makes a chair out of it 3 years from now? 3 years from now. Yeah, but right now this is a chair. But what was this chair 25 years ago? No, this is plastic. This is plastic. I mean, this was a glop. A thought. It's a glop of chemicals. Yeah, so not only do we define the boundaries of chair, but you guys are thinking of like right now, what about last week, last month? What was this chair? What was the water glass? What was the water glass 10 years ago? Sand. Probably. So we're introducing this early on in the training, and one of the things that's not immediately obvious is this is the kind of thinking that created the sleight of mouth patterns in terms of the modeling of sleight of mouth, but they were modeled linearly, and I'd like to propose for those of you who've ever studied sleight of mouth or who know anything about them, that sleight of mouth patterns were created linearly and sequentially, and they were modeled linearly and sequentially, and they're not. They're not that. Or let's put it this way, they're not just that. One could do this linear and sequentially, but it's not just that. I want to open that thought as you think about it. The sleight of mouth patterns, by the way, in case you're wondering, are in chapter 7 of our notebook. I'm not suggesting you'll want to look at them tonight and figure out what they are if I said they're not linear and sequential. Do you see how this kind of thinking can change your thinking? Because what is not problem 5 years from now? What is not problem 5 years ago? It's not just time, is it? There's all kinds of ways we can look at it. So the thinking of the problem defines the boundary conditions, and this is how we find them out and also how we run over them. What if not that was not a chair? Now what if we have not chair and not that? Or how about I see a chair? That's even more fun. Are you ready for a big one? Okay, well, how about if we do I see a chair? And so what happens if you do not I see, not chair? Which is the question of if a tree falls in the wood, does anyone hear it? Now in the book by John Gribben, In Search of Schrodinger's Kittens, and there's an experiment where they put a cat in a box. They put a cat in a box. And in the box they put a radioactive isotope which will kill the cat. If there's actually a 50% chance it will kill the cat. Then they close the box. And the fact is that since we don't know what the radioactive isotope is going to do, we can actually go out 100, well, if the cat lived 100 years, we can actually go out 100 years. Let's say 5 years. We'll go out 5 years and open the box. And depending on the chances or the percentages, the cat is either alive or dead. But the cat has been alive or dead for 5 years. Now, what's not possible in quantum physics is to predict whether the cat is alive or dead with any certainty. And someone else opening the box could open the box and the cat could be alive. Equally as much. But our active observation causes the cat to go back and be dead for 5 years. Now that's interesting. Here's how they actually discovered that. And this is on wall chart number 7. Source of light goes through some slits. And if we project this light through slits, what will happen is we'll get on the back wall, which is the bottom of the page, we'll get a bunch of light and dark bars across the back wall of this experiment. At the bottom of your page, the light is being projected through the slits. Now, the interesting thing is if we measure the light as it's projected, what we'll find is that the light will go through and it will create those bars, thus acting like what? A wave. This is actually interference patterns that are a wave. So this gives us wave interference patterns. But if we measure the light like an individual particle, a single photon, what will happen is we'll find the photon down any path of probability that we measure it. Whatever path of probability we measure it at, we'll find the photon. Whatever path of probability. So if the light could go through this way and then this way and make that bar, and this way and that way and make that bar, and this way and that way and make that bar. But if we measure it down this pathway over to here, we'll actually find it there. It's almost as if the light sends a photon particle down every path of probability until the very last moment when it actually chooses a single place and goes there. Interesting, huh? That's why we can't predict whether the cat will be alive or dead. And that's why if we open the box, another observer could find the cat alive and we would find the cat dead at the same moment, because it's impossible to predict what will happen in terms of that. So, in fact, our observation affects the observed. In the same way as we're defining the boundaries, of this by our language, what is chair defines what is not chair. Are you with me? Is this stretching your brain at all? I hope so. Let's look at page 2.7 and slide number 22. There are some things we can use to directionalize our language. There are some things we can use to directionalize our language. This, by the way, is the connective glue that holds together the languaging. Remember I said we talked about connective glue? And is just one of them. Or is another. Not is another. Not equal to. If then, and then less than, greater than. Either or, which also includes neither nor. Two things as being equivalent. Any cause and effect statement. And universal quantifiers. These are the major predicates from predicate calculus that hold together our glue, that hold together the glue of our language. Okay. Now let me just suggest what we can ask a person to consider now. With these two sets, page 2.7 and 2.6, with these two sets of language, we can actually move our language in a certain way. We can actually cause our language to move from one place to another in a way that behaves as though it was quantum without regard to content, although content will be important, as we'll see in just a bit. Because the issue for content is we have to light up the neural networks. Remember we talked about neural networks with regards to a stroke victim, which is a very important question. Now we've got to light up the neural networks in order to have the problem be something that we could run through a little bit differently and change the neural network patterns. Okay, so think about it for just a minute. And I'm not suggesting that will be something easy to do, because as you think of one time you've succeeded, have you ever talked to a client and said something to them and they couldn't hear what you said? They said what? How many people have ever done that here? Good, you guys were already using this. And when the client heard that, it was impossible for them to process it. And what you did was, you moved probably, you asked them to consider a non-mirror-image reverse to what they were thinking of, and you moved them in an inductive direction. Oh, we've got to talk about induction and deduction, don't we? So let's talk about induction and deduction. Then we'll come back to the predicates and we'll see how we can use this. Page 2.8. So deductive thinking is, since I can't turn over this rock, I probably won't be able to turn over other rocks. And inductive thinking is, if I can learn to do this, I can learn to do anything. In deductive thinking, we start with a big picture, and we chunk down to details, right? Sherlock Holmes was very famous for that. But look at the diagrams on page 2.8 and notice which one would expand a person's consciousness and neurology more. Induction. Now the problem with using induction is, if a person doesn't have a pot to hold it in, you're not going to blow the boundaries on it. So most teaching has to be done deductively. But if a client's got a problem, do they have boundaries? You betcha. If the client has a problem, do they have a pot to hold it in? Yeah. So if a client has a problem, then an inductive pattern on the problem is going to be very good. So client says, I can't imagine that. You say, how can you not imagine that? Perhaps you can imagine how you'll change. Now, if you look at the pattern itself, there's three elements that we're going to use. The first element we're going to use is the Cartesian coordinates, or the Cartesian logic from page 2.6. Anytime, and you're going to do this as homework too, aren't you? So anytime you think of something, what I'd like you to do is I'd like you to consider that that's the theorem. Just for the next couple of days, it'll be fun. Anytime you think of something, I'd like you to consider that's the theorem, and I'd like you to consider the inverse, the converse, and the non-mirror image reverse of it. and run that through your head. And notice that that kind of thinking is what's going to allow you to begin to be able to think circles around the clients that you work with, and thus to give them new neurological choices in a way which is actually quantum. And you also see, can you see that you can directionalize your language in a certain direction? You can directionalize your language in a certain direction from either abstract to specific or specific to abstract by starting with a single concept. Can you think of one thing you know that's made a lot of difference in your life? In fact, have you ever learned something that changed everything? Have you ever learned something that changed everything in your life? Just one thing. That's, by the way, an inductive pattern. Have you learned one thing that changed everything? Have you learned one thing that changed everything? Okay. How are you guys feeling? How's your brain? Good. Good, 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 good. Good, good, good. You're right in the right place. Okay? By the way, I forgot to mention this earlier on. Let's do a quick backtrack and an ecological check. I'm going to ask you to think in new ways. Does that mean you're going to have to blow out some of your own boundaries? Yeah. Are we doing that now? Are we right in the middle of it? Was I teaching this segment deductively or inductively? Mostly inductively, right, in terms of what the process was designed to do, by the way. That was on purpose. I warned you guys earlier on. I warned you about him. So when the boundaries get blown out, what happens is you'll find that the person goes into confusion before the new model gets put in. I mean, one might notice that. I'm not suggesting that you will, but a person might notice that. I'm saying you're definitely okay. You knew that. What I'm saying is during this training, especially, it's important to allow yourself to be comfortable with confusion. knowing that you're integrating to a new higher level. Do you know what that's called in quantum physics? It's called the bifurcation point. It's called the bifurcation point. I think it's one of the laws of thermodynamics. And what it says is that entropy will increase up to a certain level. In fact, if you look at wall chart number 8, there's even a diagram on it. What it says is that entropy will increase to a certain level when what happens is that there's a crisis. In quantum physics. In the case of the human being, what happens is that there's confusion. And then what happens is it comes out of that and there's either more entropy or more order. So we move on to a certain level, a newer level of order. And to be honest with you, in order to blow out boundaries, we need to go through this. Oh well. Because the way I see it is we could either teach you stuff or we could change how you think together. So I thought, why not?
This is the end of Tape 4, Side A.